All right, today we are going to look at lesson 3.1. That's on inequalities in their graphs. You should have a notes handout. I am going to go through the notes and give you some things to write down. So please follow along, take notes. If I start to go too fast, then pause the video so that you can catch up and then start it back up when you're ready. All right, here we go. The first definition is a definition of inequalities. And an inequality is just a math sentence that compares two quantities or two values, and that uses an inequality. You know this. You've done this before. If I write 7 is greater than 1, that is an inequality. Today we're going to look at some inequalities that have letters. That's what algebra is all about. So we're going to throw in some variables. All right, before we do that, though, you need to know the inequality symbols, starting with this one. This symbol is the less than symbol. If I take that same symbol less than and I put a line on the bottom of it, now it's less than or equal to. If I flip this over, it becomes the greater than symbol. And just like the other one, if I add the little line at the bottom, it's greater than or equal to. All right, again, I know I'm going kind of fast, so if you're not keeping up, pause the video and you can catch up. All right, we're going to use these inequality symbols to write inequalities from verbal expressions. In other words, we're going to take these words and we're going to translate it into a math sentence or a math inequality. And all you do is break it down by piece. So here goes. All real numbers x is the first part of this verbal expression. That just means x. All real numbers x is just some variable x that represents numbers. And what are they? They are less than or equal to. The less than or equal to symbol looks like this. So I just write less than or equal to. And what are they less than or equal to? -7. All real numbers x less than or equal to -7 translates into this inequality. Easy peasy. Okay, the second one says the sum of x and 6. So this one's a little more complicated, but not a whole lot. This is the first part of it, the sum of x and 6. The word sum means addition. So what am I adding? I'm adding x and 6. The sum of x and 6 is x plus 6. And that is greater than, so greater than looks like this, -3. That's it. I'm taking the words in English and translating them into a mathematical inequality. Okay, pause the video and try the next two by yourself, and then when you're ready, start it back up. Okay, hopefully you paused the video and you didn't just stare at the screen, but if you did, here are the answers. All real numbers p greater than or equal to 1.5 gets translated like this. All real numbers p is just p. Greater than or equal to looks like this. Greater than or equal to. And what's that greater than or equal to? 1.5. Okay, the next one uses the word difference. In math, the word difference is a subtraction problem. So the difference of x and 10 would just be x and 10, or x minus 10. is less than or equal to, 5. And that's it. So translating a verbal expression into an inequality just means you take the words and you write an inequality out of it. Piece of cake. Moving on. Next, we're going to define what a solution to an inequality is. And a solution is just any number that will make the inequality true, that makes the inequality true. So when you find the solution to an inequality, you're just finding values or numbers that make it true. Here's an example. This problem says list 5 numbers that are solutions to the given inequality. You just have to list 5 numbers that make this inequality true. And it says x is greater than 8. Well, what are some numbers that are greater than 8? 9. 9 is greater than 8. 10. 10 is greater than 8. 12.3 is greater than 8. 100 is greater than 8. 14. Okay, that's 5. 1, 2, 3, 4, 5. Are these the only numbers that are solutions? No. There's an infinite number of numbers. These are just 5 that I picked. Okay, the second one. Second one's a little more complicated, but not really. All you have to do is figure out what number added to 11 makes something less than or equal to 19. Well, if I add 1 to 11, 1 plus 11 is 12. Is that less than 19? Sure. Or 0, or -7, or 2.7. Okay, what if I add 8? 8 plus 11. 8 plus 11 is 19. Is that less than or equal to 19? Sure. So those are 5 numbers that are solutions to this inequality. Okay, flip it over to the backside. Okay, now in this example, instead of asking you to tell me what are solutions, I'm going to give you an inequality and a number and ask you, is it a solution? So it's a solution if this number makes this inequality true. And the only way I'm going to figure that out is to take this number and plug it in place of x and figure out whether it's true or not. So I'm going to take this inequality 2x plus 1 and replace the x with -3 plus 1 greater than -3, and then do the math. 2 times -3 is -6 plus 1. -6 plus 1 is -5. Is -5 greater than -3? No, -5 is less than -3. So the answer is no. Okay, I do the same thing with -1. I take the inequality, I replace the x with -1, and then do the math. 2 times -1 is -2 plus 1. -2 plus 1 is -1. Is -1 greater than -3? Yes. Okay, last one. 2, replace the x with -2. 2 times -2 is -4. -4 plus 1 is -3. Ooh, tricky one. Is -3 greater than -3? No, they're equal, but -3 isn't greater, so this is also no. All right, that is an example of how you check a number to see if it's a solution of an inequality.